Okay, just there we go. Limits. So, Malik, we were talking last week about limits, convergent, divergent, and periodic. Remember, and trying to tell if a sequence is convergent or divergent. It's hard to tell sometimes. So we'll have a look at some ways we can tell if a sequence is convergent or divergent. To start, have a look at this example. So suppose I have one. You should remember the answer. I did this last week. The frog spider creature. 1 plus a half plus a quarter plus an eighth. If we continue that forever, the answer here is 2, which we remember. If you look at this sequence, what type of sequence is it? Geometric, GP, isn't it? It's GP, where the A is equal to 1 and the OR is equal to a half. So you want to calculate this formula, really. You want to add them all together. So the closest thing you have is this. So let's see what happens if we put in the numbers. So the A is 1, the OR is 0.5, the OR is 0.5, and the N is infinity. Now some people may know actually what happens to this piece here. Does anybody know what happens to it? What value it is? No? So, if you have a look, not the same, if you have a look at your calculator, 0.5 power 0 is 1. 0.5 power 1 is 0.5. 0.5 power 2 is 0.25. 0.5 power 3 is 0.125. So what's happening? It's getting smaller, isn't it? In fact, 0.5 to the power of a large number will equal a small number. Yeah? So 0.5 to the power of an extremely large number, you're going to get 0. So basically what I'm saying is, this piece will become 0. So we'll end up with this, which will be this, which will be 2, as we thought. So let's try and put down in a formula exactly what we're doing here. So write that bit down as a kind of example. Yeah. So the formula I'm using is the infinite sum is equal to A over 1 minus OR, because this piece here is 0. This is what you might call the limit of the sum. Now, this formula only works because of this part here in blue. This is the only reason the formula works. So will this piece always be 0 in the formula? When will it not be 0? In what situation?
When it's infinite, I don't have that infinite.
True. But let's say this part here is always infinite because we're looking at the infinite sum. So if this is always infinite, will the total here always be 0? No, when will it not be? Yeah. Like if this number here was 2, is this equal to 0? Definitely not. Definitely not. Because what's going to happen is 2, 4, 8, 16. 2 infinity is definitely not 0. So my point is this formula only works if your OR is between -1 and 1. So this is actually a way to check if there is a limit. Yeah? Can I go down? So look here, for example, I know that this one, when I add it together, the total is not infinite. It's finite. It has a limit. But if I was to do this one, yeah, you definitely know that this one is infinite. So this one here converges, and this one here diverges. Often in the exam they ask you, will this converge or not, and why? So all they want you to say in the exam is, this one diverges because the OR equals, what's the OR here? What am I multiplying by? 2. The OR equals 2, which is greater than 1, so that's why it diverges. And here, the OR is a half, so this one converges because the OR equals a half, which is less than 1. Or if you want, you can just put this around it for only the positive. Or if you want to be extra clear, it's less than 1, but it's also bigger than -1. So in the exam, you get these 1-mark questions where they ask you, does it converge, does it diverge? And then they ask you why. So this is all they want to see in the exam. This is the reason why. You made the choice you did. So remember that. It's worth 1 mark in the exam usually. Yeah? So I have more examples to do. Can I scroll down? Yeah. So I'll just give you a little one to try. I want you to tell me does this, etc., converge? And if so, then what is the limit? And hint, it must converge, otherwise I wouldn't be asking you to do it. Okay, so does it converge, and if so, what is the limit?
Is that 3 minus plus 3 plus?
No, it's minus, yeah. Minus 3 over 2 plus 3 over 4. Yeah, okay. Some of us have answers. So, it converges. What's the value of OR? minus a half. The minus is important. So here you're multiplying each time by minus a half. So this is GP with A equal to 3 and R equal to minus a half.
Limit is t.
Yeah, and we'll calculate the limit. The limit is A over 1 minus R. Oh yeah, so R is less than 1 but bigger than minus 1, so it converges. And the limit is 3 over 1 minus a half. So that's 3 over 2, which is 2. So the limit is 2. Let's have a look at that here. So we start off with 3. And then the next term is minus 1.5. So if I go up to this 10th term, alright, so that's the first term. And then if you add the first and the second, what do you get? If I do the first plus the second, what will I get? 1.5. And then next will be 2.25, I think. If we add this now, 2.25. So if I keep adding terms together, you see I'm moving closer to 2. And notice how here it's going above 2 and under 2. So it's approaching 2 from both the above 2 and below 2. Okay, so you can see it's kind of jumping above and below the 2. Let's go up to 20 just to finish this one. So you see it's very, very quickly getting to 2. Yep. Okay. Now, next. So let me just clear all that. Now, is there another way to think about this? Well, there is. So we'll go back to the example I did at the start. 1 plus a half plus a quarter plus an eighth, etc. What does this equal? Well, we know it equals 2. Let's see if there's another way to check that. So what you could do is you could say let R equals a half. What does R squared equal? Quarter. R cubed, an eighth, 1 over 8, etc. So this problem now becomes this problem. 1 plus R squared plus R cubed. But if instead of using R, I use x, you would get 1 plus x squared plus x cubed, etc. Does that look familiar? You have seen that somewhere before. Where?
Geometry.
No.
Algebra.
Where? Say again?
Algebra.
Not quite.
Long division.
Which lesson? Long division lesson. Which problem? Oh, how could you forget? How could you forget? This one. So when we divide this in, what did we get on the top? Do you remember? Yeah? So this here is exactly the same as 1 over 1 minus x. Which, you know, is the same thing as 1 over 1 minus R. Which is 1 over 1 minus a half. Which is 1 over a half. Which is 2. So this just gives you another reason why this formula up here is true. Because it should remind you of the long division. That if you did this long division, what you would get up the top would be A plus AR plus AR squared, etc. You could check it. You get the same thing. Okay, next type of example. So, what I want people to do for me on their calculator is make the first 6 terms on their no, first 4 we'll say. So on your calculator, give me the first 4 terms for this sequence. What's the name of this type of sequence? Oh, come on. Couldn't have been that good of a Chinese New Year. Some of you aren't even Chinese. What's the name of this sequence? Begins with an R. Recursive. Do you remember this word? Nope, all gone. Anyways, whatever its name, give me the first 4 terms. So let's see here. Right, so what's the second term? 5 over 2 or 2.5. The next term? 2.8. The next term? 2.93 roughly. So, do you think this sequence is convergent, divergent, or periodic? It's convergent. What do you guess it's convergent to? Probably true. Yeah, we think. Okay, let's have a look here. So the first term was 2, and then the next term was 4 minus 3 over 2 was 1.5, 2.5, 2.8. And you see it's really quickly gotten to 3. Yeah? But maybe it's not 3. Maybe it's some answer like this. Maybe it's let me see.
29999.
Yeah, or maybe the limit is not going to 3. Maybe it's going to something weird like the square root of 8.41. You've no way of knowing that for certain. We just think it's going to 3, but maybe it's going to some surd like this. We don't know exactly what it's going to. Okay, we just think the limit, which I'll write like this, is somewhere near 3. We want a way to find it exactly now. Okay, so the trick comes here. So let me call this the nth term. And this is the n minus 1 term. If you compare these two values, what do you notice about them? Well, they're the same, right? Would that be true at the start?
No.
No. Would it even be true here? No. It only really becomes true much later in the sequence when it's reached its limit. Then it's become true that the value for the n minus 1 and the nth term is the same, or at least nearly the same. So what we can do here is we can replace both this and this with x. We are looking for a value of x that will make the last term and the next term the same. In other words, we want to solve this. And this little trick works really well. So let's see what happens when I try to solve this. Any ideas? What do I do first to solve this? What can I do first? Yeah, I could move things around, but the easiest thing to do first, what would be this? Multiply by x. So if we multiply by x, I get x squared equals 4x minus 3, x squared minus 4x plus 3 equals 0, equals 0, x minus 3, x equals 1. X minus 1. So x equals 1 or x equals 3. Now this one shouldn't surprise you. This is what you thought it was. So you can say that the limit equals 3, which is true. It is moving towards 3. So this is a good way to calculate the limit. Yeah, how about the other one? What's the story with this guy? So is it wrong? Well, not really. This one could have been the limit. The way you make this one the limit is by changing where you start. So because I started at 2 here, it ended up moving to 3. If I started at 2, it ended up moving towards 3. But maybe we could start at some number that makes it move towards 1. It's possible. Maybe 0, maybe something near 0. So in the exam, how do you choose? Do you choose this or do you choose this? The only way you can know is if you look at maybe the 4th term, and then you can decide if it's going towards 3 or 1. And I think if you look at this, it's clearly going towards 3. It's not unclear. Let's see what happens if I change this to 4. See, the limit is still 3. It still goes towards 3. If I change it to 5, see, it still goes towards 3. What about if I make it a minus number, like minus 5? It still goes towards 3. Just as quick, really. Minus 100 or 1000. Again, goes towards 3 very quickly. Let's see if we can make it go towards 1.
Is it always with integer? The sum?
The which sum?
Like 3.
Oh no, this could have been like square root 3 or something. Yeah. Now, I don't think I can actually get to 1. Sometimes you get 2 answers and it's impossible to actually get to this answer here. So like if I do 0.99999, you might think I'm so near 1 that I should move to 1 really quickly. But the sequence, as you can see, doesn't runs away from 1 and very quickly goes back to 3. It just took a bit longer. Yeah. So sometimes both answers are valid, sometimes only one answer is valid. There is one way I can make it go to 1. Does anyone have an idea? There is one way I could make this sequence have a limit of 1. Any ideas?
Start from 3.
Start from 3?
It will be 3.
It'll be 3.
0.
0 would be an error because you're dividing by 0 for the second term. Any other ideas?
1.
Start at 1. Is the only way it can go to 1. Yeah. So there's a little bit of vocabulary that we will use again in the no, we won't use it again next semester, so I won't tell you what the word is. No, that's mean. We call this limit attractive. Yep. So the sequence is wanting to be to this limit. Yep. Just like you would guess what the word means. Yep. Okay. I'll give you one like this to practice. Let me go back down here. So I want you to tell me what the limit for this sequence is. And we start at minus 1. Calculate the limit here. What's the opposite of attractive? Don't say ugly. It's not that. Opposite of attractive? Detractive, unattractive, inattractive, anything else? Hideous? No, we don't say hideous limit. Anything else? You're closer with hideous than unattractive though. Anyone know it? No? Repulsive. Repulsive. Yeah? Okay, get me the limit here. And don't forget, it's a good idea to get the first 4 terms first. In the exam, you'll have to use the method I showed you to find the limit. It looks like it's going to -2. So let's use the technique I showed you. X equals -1 plus 2 over x. Here you get x squared equals -x plus 2. Here you get x squared plus x minus 2. So we have two values here, x plus 2, x minus 1. So it's either going to be the limit is 1 or -2. Now it has to be this one. We reject this. It has to be this, except this one. Because if you look at the sequence, all the terms are negative. So it really seems unlikely it's going to be 1. It's going to have to be the -2. So we have our answer, the limit equals -2, or if you want you can write it like this. Or sometimes people write it like, x is going towards -2. They all mean the same thing. As n goes to infinity. So you can write your answers 3 ways, whatever you prefer. Question? Did I make a mistake? No? Question? You can ask me.
Yeah, because the first item, -1, that's the same or is 1.
This one here is 1, and this one here -2. So all of these are minus?
No, I mean the x1 and x2.
Yeah, -1, -3, yeah.
One bigger than -3 and one smaller than less than denominator.
Oh, I see what you mean, that this one is bigger than -2 and this one's smaller than -3. Yeah, that's another reason as well, that it looks like here's -2 and it's going above and below -2. Yeah, so yep, that's another reason for picking this one and not picking this one. Okay, can I do that next type? Okay, so I'm going to give you another sequence, but this one is explicit. Yeah, it's explicit over 18s. -4n squared plus 2n. So this one here is not recursive. You just put the n in the formula. So, for example, what's the first term here? T1. Well, it will be -5 plus 8 plus 5 over -4 plus 2. Which is, let me see, that's 18 over -2, that's -9, and is 9, is it?
Yeah.
Yeah. And then you can have T2.
-9.
Is it? I'll have to calculate it. Have you calculated already?
No, the first one, minus.
Oh, it's a minus, is it? Well, you know what? I'll just make it here. It is 9, okay.
I can see the outside.
Ah, no, that's okay. I want to make the first few here. Did you write the formula down for it? Do you have this formula? Now, write this down and then we'll make the first few terms. So we'll go up to T4 again. Have you got the formula?
No.
Yeah? I just need you to read the formula back to me. So the formula is minus, okay, what's on the top?
5 and 4.
Okay, 5, whoops, 5 times n squared, yeah?
Plus
Plus
8n.
Plus 3n,
8n.
8n
Plus 5.
plus 5 divided by, okay,
Minus 4n squared.
minus 4n squared, yeah?
Plus 2n.
Plus 2n.
N.
9 for the first one. Then when you put n is 2, did anyone get it?
41 over 2.
And what's that as a decimal? Yeah, 41 over
3.4.
2, yeah.
3.4, is it?
Yeah.
Yeah.
Yeah. So let's calculate, let's go up to the 10th term. And let's go up to the 20th term. That's not 20. Let's go down to 100. See, it's not clear what the limit is here, but it's something like 1.27. Maybe it's 1.25. But it's very easy to jump much later in this sequence. You could jump straight to T10 or T 1,000 or T 1,000,000. So it's very easy to jump to a large number here. I think if you go to 1,000,000, you get something like 1.26, something like this. Okay. So the question is, how can we calculate T infinite, the limit? Does anyone have any ideas here? You want to know what this is moving towards as the n gets bigger. Does anyone know the method for this one? No? Any ideas?
Any clue?
Huh? A clue? No. No clue for you. So, one way you could estimate the answer is by just putting in a big number. But the problem with this is it's not exact. But what we can do here is we can simplify this a little bit. We can divide everything by n squared. So this becomes 5. What would this become? I'm dividing everything by n squared. 8n squared over, 8n over n squared, which is just 8 over n. And the last one? 5 over n squared. Now, divide everything by n squared. Minus 4 plus 2 over n. And that's it. Will this formula make the same sequence? What do you think? Will it make the same sequence? It will. I mean, if you put in T1 and calculate, you'll get the same sequence. There's not going to be any difference. Yeah. So now, does anyone have an idea on how I can calculate this? If it's written in this form. No? Impossible? Impossible? Nobody knows? No?
5.
No? Okay, I'll tell you. I'll tell you. When n becomes very big, what happens to this number? If the n is really, really big,
Small.
it's really small. And if n is infinite,
Means
really small, 0. Here, 0. 0. So you're left with 5 over 4, 1.25. Ah, no, 2 minuses cancel here. Yeah. So the answer is 1.25, which is what we thought. Earlier we had a number like 1.27. Yeah. So this is the limit here. So the trick is to divide by the biggest n. In this case, n squared. This is the trick here. Okay, you should write this one down since nobody knew this one. Nobody's seen this trick before, no? This is new? Or you've seen it before but you forgot? No, it's new.
Since 4 years.
Maybe, okay. Okay, there's one last example to look at. Then I'll let you try them for a few minutes. I want to have a look at your work from last week then. Okay, can I go to the next example? Yeah. Off the phone. Okay. Right. Everybody knows what this is equal to. If it continues forever, this is equal to 1 over 3. You all know this. You all know this. So the question now is, if you had a number which was repeating but not as simply, so like for example, if you had something like 1 point, I don't know, 2, 3, 2, 3, 2, 3, etc. Like this. Whenever a number repeats like this, you can always write it as a fraction. It's always possible. So in fact, I know that this is equal to 122 over 99. So the question is, how can you get this 122 over 99? Okay, so let's have a look at this example. So first step is you separate it from the number part and the decimal part. So you write this as 1 plus 0.232323, etc. And if you look at it like this, 1 over 1 plus 0.23 you need to focus on this part because this one is already a fraction. You need to look at what you can do for this part. Yeah? So what you do is you identify what's repeating. So it goes 2, 3, 2, 3 and 2, 3. So we can write this now as 1 plus 0.23 plus 0.0023 plus 0.000023, etc. Okay, got that so far? Yeah. Then what you do is you write each of these as a fraction. So let me see, that would be 23 over 100. And that would be 23 over 10,000? Is that right? No. Yes?
Yeah.
You sure? Hmm? No. Yes. Sorry. It is right. Okay. And then this one here would be 23 over 1, 2, 3, 5, 6 zeros. Then what you can do is you can change this into 23 over 10, and this one would be 23 over 10, no sorry, 100, sorry, 100, no actually I do want to go back to 10, yeah.
Multiplied in by 1.
Sorry, this is 10, oh my goodness, this is 10 squared. Oops, my pen's gone. 10. Sorry, 100. Now, how many zeros have I got here? 1, 2, 3, 4. 100 squared. Yeah. Yes. And then this one here is 100 cubed. Okay, good, good. Okay. So this one here is 1 plus, and then you can take the 23 out if you want. You don't have to. I'm going to write it like this. 23 times 1 over 100 plus 23 times 1 over 100 squared plus 23 times 1 over 100 cubed. Now if you look at this, this is almost geometric. What are you multiplying each time here? You're multiplying by 1 over 100. Yeah? But it's not quite geometric. What's the tiny problem?
The A.
The A is not quite right. Where would you love to start? What would be the... Well, yeah, well, what number would you love to have at the start here?
1.
Not 1?
1 over
23. So why not? You can change this into 23 plus 1 plus 23, because these two here, they cancel. 23 plus 23 times 1 over 100 plus 23 times 1 over 100 squared plus etc. Now when you look here, this is GP. The A is 23 and the R is 1 over 100. So now, let me see, when you put these two together, you get minus 22 plus A over 1 minus R. That's the formula we had from the start. So that's minus 22 plus 23 over 1 minus 1 over 100. That's right, isn't it, John? Which is minus 22 plus 23 over 99 over 100. Yeah. Which is minus 22 plus 2300 over 99. Getting to the answer. Now I'll put this as a... if I put these together, this will be minus 2178 plus 2300 over 99. Which equals 122 over 99. Which is what I said at the start. So, let me zoom out a bit here.
Why do we need to get that much data?
Yeah, what good is this to anybody? There's no good reason. It's just something that's on the exam. Oh, 4 or 5 marks. But you see, there's different ways you could go about it as well. In fact, there is a quick way. There was a quick way to do it in your head, but you can't do it in the exam because you need to show your work. Does anyone have a quick way to do this? No? In your head, what you do is you break this up as 1 plus 0.232323. And then what you do is you take these numbers that are repeating and you put them over 9s. And you need the same number of 9s as you do numbers on the top. So for example, if you had 0.123123, you would have 123 over 999. It's the same thing. So this here would be 1 plus that, which would be 122 over 99, which is what I said all the way down here. So this is a way you can check if you got the right answer. It's a kind of quick way to do it. And look, this even works for our friend 0.333. 3 is repeating, so we put 3 over 9, which is right. 1 over 3. Yeah? Okay, write this down, so. Right, so what I want you to do for a few minutes is do the last two in each. The last two. Yep. Huh? Too blurry. Can you still see? Okay, so the last two in each. Let me have a look at your work last week. What do I want to have a look at? Oh yeah, what I really want to have a look at is how the geometric worked.
9 and 10. We did, no, 8 and
8 and 10 was a problem?
10. Mostly in 10.
10 was a problem. And we did 8 in class, didn't we? 10 was a problem, yeah. How was the geometric? This one. How was it? No problems? Did you get number 10? No, that's okay. You get number 10? No, okay, no problem. Huh? 9 and 10, yeah. I mean, you tried it, yeah? And no good. That's okay. We'll do this on the tutorial then. Yeah. Ready? Haha. You're a fresh book. That's okay. Can I close this? Yeah. Okay, I'm gonna close it.